Welcome to the project demonstration of dual transformer health monitoring system using Blynk application along with alerts notification and controlling the loads with the help of this electromagnetic relay. So in this version we added the two features, like one is oil level with help of SR04 ultrasonic sensor and oil quality with help of this turbidity sensor. So coming to the ultrasonic sensor, so it will measure the distance from an object surface. So it doesn't know whether liquid or a solid. So when we are placing this on top of the transformer, so it will check the distance of the oil. So if considering we place the distance for 100 centimeters, considering that 100 centimeters is the distance height of the transformer, so whenever we fill it fully oil, then the distance from the surface of the oil to the ultrasonic sensor is very less. So then it will considering as a oil level is high, and when the oil level is decreasing, so then automatically the distance will increase. So based on the distance increasing, we set the limit for the distance limit is 60%. So whenever it is below 60%, then it will isolate the power supply to the transformer connected load, that's a T1 load. So as we are measuring the transformer 1 oil level and transformer 1 oil quality, and like that the oil level will be measured and controlling the load. Parallelly we are going to measure the oil quality with help of turbidity sensor. So whenever oil quality is very good, then the transparency of that particular oil is very good. So nothing but when the oil is damaging, then the viscosity will be increasing, and then thickness of the liquid will be increases, the oil will be increased, and then light passing through that oil will be decreases. So based on that, so there are the two, one transmitter and one receiver. So when we place this in a liquid, then if the thickness of the oil is more, means oil is it to be damaged, then automatically the light passing through that oil will be decreases. So based on that we'll get the variable voltage, and that will be identified by the PIC 16877A and displaying on the LCD screen. So remaining all are same, like high voltage, low voltage, high current for the transformer 1. So high voltage, low voltage, high current for the transformer 2, and high temperature. So remaining all are same. So let us see the demonstration. Before switching on this kit, enable the hotspot in your phone. So with project 4924. So right, and password should be 129. So all are small letters without any space. And after that, switch on the kit. After enabling the data and the hotspots, switch on the kit and place an object here. So it will be considering as a high oil level, so normal oil level, and go to Blynk application. So there we can see the live data is continuously streaming to the Blynk app. So whenever the oil thickness is more, means light unable to pass from the transmitter to receiver, so then we can see the light is off on the turbidity sensor. So we'll get the alert notification, need to oil reclamation, same message displayed on the LCD also. So if you place in the water, so we'll get the oil quality is 188%. So then we will get the oil level also very low. Next, oil level, low level, and we'll get the message. So coming to the variable voltage and variable current. So generally the current will be varies when we connect the load. So but we are getting the same voltage as we are using the transformer for get connected one. So not 230 volts continuously will get that. So 230 volts AC can't measure by the microcontroller. That's why we are converting that. So AC to DC with help of this rectifier, and 230 volts AC to 12 volts AC transformer, and AC to DC is a DB107 rectifier, and capacitor will make the smoothing purpose, and next 7805 regulator will provide the 5 volts output. So that will be changes with help of this potentiometers like for inputting varying purpose, we are using the variable resistors. So the variable resistors will vary the voltage from 0 to maximum of 5 volts, so that controller can measure it easily. So but we are using a potential divider circuit as a variable resistance R1 and R2, so that's why we are going to converting that 0 to 5 volts to 255 volts maximum. So that is a potential dividing circuit purpose. Okay, the ratio is going to be, the potential dividing is 10:1. So if we get the 1 volt, so then it will consider as a 50 volts. Sorry, 10:1 is what, 1 volt is the much 10 volts. So like that the formulation will be occurred from this potentiometer by using the microcontroller.